Hello, do you hear me? I have no sound on my side.
Yes, I can hear you now.
Perfect.
Like yesterday, you're a bit low in volume. As
Okay,
usual,
I try to fix it.
minutes to join, if you don't mind. So I guess the 5 minutes are past, and we have to start the meeting. By the way, you see the old LP1-SCHC logo, and I think Anna is working on providing us with a newer and better logo. So Anna, if you have your slides at some point, it would be very nice that you share the possible drawings that we've discussed. So we vote on what's going to be the new look for the working group logo. And so with this, I see Alexander is not with us. So not well, this is the IETF meeting. So all the best practices apply. In particular, all the anti-harassment procedures and the patents and copyrights procedures. So if you're not aware of those procedures, please look at the best practices that are linked in this slide. If you feel that you're being disrespected by participants, you may contact people from the Ombuds team, which is the link that's given to you. And if you're aware of any IPR in the discussions, please let us know, undisclosed IPR, please let the chair know or say it during the call, or refrain from giving any information about, or refrain from using the IPR in our discussions, basically. So the agenda for today is very limited. I asked for subjects and did not get any. So the goal is to continue the discussion we started at IETF-117, and that people from the architecture document have been continuing. So it has to do with the way we do SCHC headers, the way we encapsulate SCHC in UDP or natively over IPv6, and what that means in terms of header chains when you have multiple layers of SCHC, one after the others. And Laurent, I hope you have some slides. I mean, I've not seen them imported on the...
No, I don't have slides, for I have some in my computer. I can show some discussion we have, but I don't know if I can
if
show.
you don't mind, you still have the capability to upload them on the site. So unless there is the data tracker meeting interim page. So I can share the link if you don't want for it. Let me go on the chat and just share the link on the chat. So this is what the session is, and you can upload your slides from there, and I will import them in the meeting. Okay, so that's the topic. I mean, agenda bashing. Is there something that somebody wants to discuss beyond that agenda? I'm hearing nothing, so let's move to Edgar. Yeah.
Yeah, just I think I can take it in the other business, but yeah, a little bit information about what is going on in 3PP with reference to the energy devices.
You know what, Edgar? I would love to hear it before we start diving into the architecture effectively. So if nobody minds, right after the opening, I will give you the ball for you to tell us the news.
Okay, sure.
And since it is now, so Edgar, please go on. So what are the news?
Okay, so now it has been started to be discussed what is the scope of the zero energy devices, so what devices will be considered for a standardization so that they will connect to the networks. There have been basically three types of devices being described, from very, very simple ones, basically almost a sticker type of device. So they are this backscattering, all the way to devices which might even have a battery or some kind of high capacity capacitor, so that they might have more possibilities. So at the moment, there is still a discussion which of these devices should be started the standardization. It might be what my thinking, what will happen is that most probably we will start with the more complex devices. So the ones that are still gathering energy from different sources, it can be solar, wind, or even RF, but RF is not so efficient at the moment, but well, it could be also. And then they have this capacitor, so they are a bit more capable devices. So then that is at the moment being studying, and we are also thinking that CHC will have a very good fitting for reducing the energy consumption needed for edge transmission. So then we have a plan to submit actually the first version of a draft explaining these kind of let's say characteristics of the zero energy devices and what could be the needs and requirements for the cellular network and what characteristics of CHC address what problems and what is the gap. So basically that was what I had. So the idea is to maybe start with the first draft 0 for Prague to have already a first version. Any comments or? Yes.
Hello all. Hello Edgar. Thank you for the information. Can you mention what release this is targeting, please?
Could be release 19. I think I have heard that it might be the one where it comes.
Okay, very good. And so you said 3 categories from the very simple backscattering device to the full featured.
Yeah.
The one you mentioned with scavenging, is that the second category or is that already the third one?
Which one, sorry? Can you repeat?
You mentioned scavenging with a solar, wind,
scattering.
and capacity.
The scattering, the back scattering, you mean?
Right, that was the simplest one. And then you
That's
mentioned
the simple, yeah. Then
scavenging from solar and wind. So is that the second or third category?
It can be, let's call it type 1. So type 0 would be the one, the backscatter. Type 1 is, it can be that one, but it has maybe a very small battery or a supercapacitor. And then there is a type 2 that could have rechargeable batteries. So it can be either 1 or 2.
Okay, very good. Thank you.
Welcome. Yes, Sergio, you have a question?
Hello, can you hear me?
Yes.
Yes, well, I would just like to mention that I will be interested in looking this draft and helping in any of the on anything that is required.
That would be great. Sure. Welcome.
Excellent. Just let me know, and we can meet or anything.
Sure. If you can pass me your contact information, I can contact you later on for that.
Excellent. Thank you very much, Edgar.
Okay, that's it. Thank you, Pascal, for the time.
By the way, I realized that I have not created the HDoc file, so somebody is editing. Thanks so much, because they did not create the usual minutes page this time. Okay, so yes, the architecture, I will be paraphrasing a little bit what we discussed last time at the IETF 117 about the encapsulation and the CHC headers. If you remember, CHC can work at every layer, and you can even have CHC compressing some PDU from some layer, and then compressing later another layer between different pair of nodes. For instance, you can have end-to-end application PDU, a PDU being compressed by SCHC, which means there will be a descriptor for SCHC explaining which session that is between those two application endpoints. And then maybe at the transport level, and then maybe over one link, you will have SCHC as well, meaning SCHC will operate several times inside the same packet. And what SCHC produced for the inner piece will be a binary blob for the encapsulation SCHC piece. And so we have to describe how that works. And it could start at layer 2, and the SCHC over PPP draft is like that. Basically, we have to describe in the PPP header which session we're talking about, and we map the SCHC session to the PPP session. And then you can do it at layer 3, meaning that we need something like a header, an IPv6 extension header to provide the SCHC information, or it could happen even inside the application. And you realize that the formats may change, but the information that SCHC will need is always the same. You need to, and we'll see that in more details, but you need to identify the endpoints that are compressing and decompressing. So you need data identification. Then, if there can be more than one SCHC session in parallel, you need a session ID. And depending at which layer you operate, you might want to protect the content that SCHC has produced by some form of CRC. And so that's what led us to the definition of the SCHC header that I will present you. Now, the SCHC session is something that we've started to discuss in the architecture document. And we realized that the two endpoints, it's always a point-to-point thing to start with. So the session endpoints, it's always two nodes. For now, we don't have a multicast SCHC. It could happen, but for now, it's always point-to-point. Not only point-to-point, but we also have this concept of a role, whereby one node is the device and one node is the network. And that really inherits from things like LoRa or Sigfox, where the device, was the low power thing, and the network was really a system entity connecting to many, many devices. And part of the things that the architecture will have to describe is how you set up the session in the two endpoints. In the usual low power device, it's hard coded. There's only one session, and it starts when the device boots, and you just keep on like that. But when you have more capable IP endpoints, which can have many sessions with different other endpoints, then you will have to bootstrap the session to provide enough information on both sides. And that's part of what the architecture has to describe, which is information that both sides needs to have. What is in that information, what is resynchronized must be the same on both ends, and what is more context that has to live on both sides, like counting the frames or whatever. And part of that will be effectively where are the rules and where are the data that are needed to bootstrap this session. So what kind of network management do we put in place? Is there some network management that pushes all the rules to the endpoints, or network management provides a URN for the rules and then the endpoint goes and fetch the URN? So all those things have to be discussed. Now, once we have set up the session and managed it, etc., and like I said, it's one big thing that we have to discuss. Then we have to look at the data stream. How does SCHC fly over the different layers? And in particular for this picture, how does it fly over IPv6? Like if you have an IPv6 header, and you want to compress UDP and above, for instance, how does that work? How does endpoint A know that the packet that it receives from endpoint 2 is for this particular session? And so we realize that at least abstractly, we need a container for that information. For all the information that SCHC needs, including the session ID, we need a form of container. And that's exactly what IPv6 extension headers are. So we started defining, hey, based on the data we just discussed that we need to identify the session and stuff, what would be in this header? And for now, we realize that it's formatted like a classical, usual IPv6 extension header. So we have next header, header length, but then we need a checksum just like UDP would, and we need a session ID. And for now, that's all we have, but we keep the capability to extend it with options. Now, we need this header. It doesn't mean that it will fly in the packets, and we'll see how that goes. But we need it, at least abstractly, to conceptualize what happens in the stack before you compress everything. And so if we look at a packet, which is normally issued like, an IPv6 header, let's say you don't have any extension header, so the next header field in the IPv6 header says upper layer protocol is URP, then you have a URP header, think UDP, TCP, blah. And then after the URP header, you've got the protocol data unit that goes with that URP. Now, if we want to compress above IPv6, we basically need to signal the compression session and all the session information inside the packet to describe what goes after. So that means that at least virtually somewhere in the stack, you have to insert that SCHC header that we just showed so that the packet looks like the second line. I mean, the next header now in the IPv6 header says check. And in the SCHC header, then you say your next header is URP, and now you have a proper IPv6 chain. Yes, we probably will have a hard time getting Sysman to give us a number for that SCHC header if we say the header flies in the air. But actually, it does not. We'll see that as soon as we've done this, the next step is to effectively compress based on that. So the first step in that compression would be to effectively compress the URP and the URP PDU and say you don't have nested SCHC here just for the sake of simplification. And then Laurent will talk later about nesting. But basically what SCHC will do based on a set of rules is compress the URP header and URP PDU. So all this now becomes a rule ID, and say it's not fragmented, but it could be. So rule ID explaining, which rule was used to compress, the black and the purple things. And before that, you will have the SCHC header indicating which session between the two endpoints, the two endpoints being the source IP and destination IP in the IP header. So which session contains the rule ID that is used to compress the green thing. So and that could fly in the air, but like I said, IPv6 people will tell you that no, don't do any new header. The firewalls will not like it, etc. They will not like it. But the next step is probably to compress that anyway. And so when you do this second compression to get a native green SCHC PDU, you could, if you don't do any nesting, say, I've compressed everything in one shot, including the SCHC header. But that means that the thing that compress the SCHC header, or the rules that compress the SCHC header, are lost, are part of the description for the compression of the URP, and that's not architecturally correct. I mean, there should be, this is layers. You have a SCHC layer and you have a URP. You should really have rules which describe how you compress the red thing, and then rules which describe how you compress the black and purple things. At least one remark here is, since we have placed a checksum in the SCHC header, which protects the SCHC header as part of the rest, this checksum also protects the black and purple things in their compressed form, meaning that you don't really need to transport the UDP checksum, that you can save those 2 bytes, because you know that the URP black and purple things are protected by the checksum of the red thing. So that's why you see in this picture, if we were to do that, we'd probably elide the checksum in the UDP piece because we have the checksum in the SCHC piece. So the black checksum would be elided because we have the red checksum. In the red piece, we would have to find in line at least the checksum in the session, because if you have multiple sessions, then you need to identify which one. Now, like I say, it's a lot cleaner, architecturally speaking, to split the 2 SCHC sessions. The SCHC session that compresses the URP, and the session ID for that would be indicated in the red thing, and then the session that compressed the red thing. Then you realize that we have nowhere in the blue header to indicate which session SCHC is, which tells you that it has to be implicit, it has to be well known. So what we're getting at is, if we compress the SCHC header, so the red thing, then the rules to compress it, to decompress it, I'm sorry, at least all the way to get to the SCHC session, that piece of the rule must be well known. It has to be hard-coded because there is nothing before to signal what it is. Once you've extracted that, then maybe in the SCHC header, you could have additional information to say, hey, I've got SCHC options, and yeah, there is a session to decode my SCHC options. But at least to decode what we have shown earlier, let me go back. The SCHC header, at least to decode all the way to the session ID. And this must be hard-coded. It must be always the same, because you need to decode the SCHC session. Now, let me show you again the SCHC header. If we decide that we have options, then the session ID to decode the options should also be in line. So we have to figure out how that works if we want to have options, and if it's not just the first 6 bytes. The other comment which is interesting is this is an 8-byte thing. That's the first 2 lines. They have to be 8 bytes because IPv6 aligns the headers, which tells us that we must have a padding rule in there. And if the header length is in line because it's not the default 1, actually 0, I guess. But if it's not the default, meaning that there are options, then the header length must be in line. And so we have to be able to pad all the way to the 8-byte alignment after the options, which also tells us that probably we might look at a rule that we don't yet have, which would be a padding rule. And I don't think we have a padding rule. But remember, when we expand this header, we must be aligned to 8. So just a side concern. But okay, back to this description here. What we said so far is, ideally, we have 2 SCHC sessions, one for the PDU2, which is the URP, and one from the SCHC PDU1, which is SCHC itself. And we said that the code should hard code enough to be able to at least know where the PDU2 starts and what session that is for the PDU2. And then if the checksum in black is elided, then have a checksum in red that covers the red, the black, and the purple. That's what we said so far. Last but not least, if we leave a local domain where this SCHC format would be accepted by the firewalls and want to go across the internet, then we probably need to encapsulate SCHC into UDP. So even if the upper layer PDU in black is like TCP, just we still need to encapsulate the whole thing in UDP to pass the firewalls. So if we are to do that, the proposal on the table is to say, okay, we got a UDP header that goes before the SCHC header. the UDP header that encapsulates everything as a checksum. Destination port would be SCHC. Source port would be the SCHC session. And so this serves as the indication of both the session and the port, meaning that we don't really need the red header at all. It's mostly compressed because the two information that it contained were the SCHC session and the checksum. So if there is no option, again, and we don't have any game of option for which there should be a session for PDU1, then we're all set. Basically, the PDU1 could be only the information of the ULP. And if in this game there is a single ULP, then the first green block, the red block basically, could be compressed to 0. ULP is well known, session is the source port of UDP, and checksum is the one of the encapsulator UDP. So SCHC header now goes all the way to 0. If you have more than one ULP, then you still need to have some residue for the first green thing, saying what the ULP is. And that's pretty much all the discussion we had at the time of IETF 117. Just we also discussed the SCHC context, like what both nodes, both endpoints have to know. And part of that context is what the RFC 8724 really called context, but that's just a set of rules. Then if we do some management, there could be amendments, and Laurent has started to discuss how to change an original rule set. Then there is the rule data, like for instance, if there is a variable in the expression of the rule, which is your IP address, we must have a set of information, so you change $1 by the real value of the IP address before you really instantiate the rules. And so based on the original rule set, the amendments, and the data that you apply on it, you really get the instantiated rules that operate between the endpoints. And so, for instance, you have your IP address and the IP address of the other endpoints, which are part of the rule data. And when you start the session, you apply them to the rule set. That gives you the instantiated rules, which is loaded in memory. But from there, the rule starts operating. You start sending packets, so you must have, for instance, fragmentation timers and some other runtime state, which tells you what you sent and where you are in your exchanges. There is a lot of state in the fragmentation piece. So all this, in my view, constitutes the context that SCHC needs to operate in an endpoint. And then this context can be managed by some network management that Laurent started to discuss as well. We really need to work on in this SCHC work. And well, that's pretty much it. We started the discussion about how we have the rules, how we write the rules. You realize that some rules maybe share the same beginning of the packet, so that they have the same beginning and then forks, if the continuation of the packets can be different. And then fork again, which tells you that the rules are really organized as a tree. So it might be something interesting to know and represent when we write a data model for rules. Like I'll say, this is the beginning of all those rules, and then this is the next, and then this is the next, and this is the fork. But that's just another side consideration. Okay, and with this, I've spoken enough. Do we have questions so far? What makes sense? What does not make sense? It's supposed to be just a reminder of what we said at IETF 117 as the base for the discussion, and then we'll have everything that Laurent wants to tell us today. So questions, synchronization, remarks?
Hi, Pascal. I lost you.
I was muted. I was asking for questions and then remarks.
That's not me.
It's not me. What do you mean that's not me? I'm hearing you.
I am delegate. I can mute you, but I didn't.
No, I was saying I muted myself because I
Oh,
was
okay.
asking people
Okay.
to. So any remarks? What do you want to take over from there? I mean, did you upload your slides, by the way?
Yes. So
So
normally,
let's manage them.
otherwise I will share my screen if.
No, it's there. I uploaded the slides, so you might share them. I see that Anna has a question. Go ahead, Anna.
Hello. So the question is the SCHC rules that we are defining for the next header and the session, are they global or not?
What do you mean global? They should be well known, meaning every node would have the same, but they would operate only above IP, right? They would compress the IPv6 extension header, not some layer 2 things and not some layer 3 things, or some layer 4 things. Because well, that's what we discussed so far. Now, if we want to start having something which is the generic rules for SCHC in general at any layer, we could also do that, but it could be more complex because, for instance, you could have to describe the URPs if you are if you don't want to inline the URP value, you would have to start listing them. But then that list would only work at layer 3, and at layer 4 and application layer, you would have no use of it. So the way I was seeing it is the rules would be, there would be a layer 3 rule for the SCHC header. That layer 3 rule would be well known. But for anything beyond that, like using SCHC for COSI, I don't know, then you would have to have another set of rules, meaning it's a different session, and anyway, the session ID applies at a different layer, so it identifies a different set of rules, etc.
Yeah, but that's the set of rules of compression, but the SCHC header rules will be known for everybody. So you are using the same format, the next header and the session ID in all the on all the layers. So the SCHC
No,
header
not,
rule is the same.
in the other layer, you would basically have to, because you have a chain of SCHC data and SCHC and data. So you would always have to be able to say, if there is another SCHC inside you, then here is the SCHC session and the SCHC endpoints. So maybe that's something that we would need. Let me work. So here we go. So if this is just if you don't nest any SCHC, but if you have a nested SCHC at an upper layer, somebody has to signal what the endpoints are and what the session ID. Probably checksum is not needed, but the session ID is, and the endpoints are. For instance, which application talks to which application. So for that, you will need a SCHC header, and you will have to indicate what session that is. So you can decrypt that. You can decompress it. And then you have this upper layer SCHC header. But I don't think it's the same SCHC header. It does not contain exactly the same. In the case of IPv6, the endpoints are really taken from the IPv6 header. So they're implicit in the SCHC header. But if you wanted to write a very abstract SCHC header which has everything, then depending on where you are, it could contain a lot of stuff. So I don't believe that there's a single SCHC header at every layer. It says it's a different one which depends on what you're doing. This is the IPv6 SCHC header.
Okay.
So to find, your rules, etc., we need to identify at the frontier, at the end of the bits, which represent some layer. If you compress an inner layer, you have to have another SCHC header, and you have to be able to find the endpoints and the session for that compression, and it has to be in line there. And there must be some readable information that tells you that. But I don't know exactly how this is done, right? I mean, the solution, we just, that's what Laura is going to present to us. We are still in the prime statement right now. If you're asking me how we do it, I have no clue. We have not decided it. It's just that for me, it's not the rules that we'll use for V6 headers. It's mostly the same abstract content, right? And the abstract content is what we have here: session ID, endpoints, which role the endpoint, the receiver, and the sender are. But the rules and the compression will be different. There could be options, there could be a sort of stuff, which depend on the layer. But that's just the beginning of the discussion, right? We are nowhere. I mean, we have to figure out how we want to do that. Do you want to speak your mind? I mean, you've got some slides that you could present.
Yes, I think if I can share the slides, yes.
Yeah, go ahead.
I think it's this one. Yes. Okay, so this is really primary work. So these slides are from this morning, and they were more used for discussion about the architecture than. So there is a lot of open question and maybe a lot of mistake in it. So it's good to have this discussion. So the idea is to look at some complex architecture. So we took the one from OSCORE draft. It means that we have 3 layers of SCHC. So we have the OSCORE layer, which means that here we compress OSCORE packet and then we encrypt them. Then we have the CoAP layer where we put CoAP and then we compress it. And we have the UDP IP layer that is only useful on the LP1 network. And when we leave the LP1 network, we have to reconstruct an IP UDP to go, or at least a IP, but IP UDP can be useful too, to cross the internet to reach the application running also CoAP and OSCORE. So that's the idea of this architecture. And so what you have also in dotted line is where we can have the SCHC header. So the good news from SCHC header is that we were using it from the beginning of SCHC, but we never noticed it. It means that if we don't define any SCHC header, so we introduce nothing on the packet. If we have a SCHC header that is all the fields are well known, we have only one rule. So one rule, we don't need rule ID. And if everything is not sent, then we have to send nothing. So we have something that is also compatible at that place with the existing SCHC. But we can introduce something where we can put some information that will be useful to manage a network. So on this nice drawing, I tried to explain what we can have if we have SCHC header at all between all the layer. So from so the first one will be at the LP1 level, then we have the CoAP and then the OSCORE. So here we start at the LP1 networks. We can have a SCHC header, and in some case, as Pascal said, the SCHC header will contain a session identifier, which unfortunately made also SID, which can be confusing with what we do in CoreConf, but has nothing to do with that. It's just, for example, a session ID, and we carry it, and this session ID will be able to identify different SCHC instance or session running on the same device, for example, or on several devices. So with the SCHC header and the SID ID, we go to a set of rules that are the one for IP UDP compression. So inside it, we have a rule ID that defines the rule we need to compress UDP and IP. And then we will have a second layer of SCHC header that will be introduced. So we have a new ID, SCHC prime ID, that will be used, and it will point to a set of rules that will be used for compression and fragmentation of CoAP. Then we have a rule ID that is used to do this. And inside, we have another SCHC header that we may have, of course, another seed ID that will define an instance for this. And finally, we arrive to the compression of score and not CoAP as shown on the slide. So we have this kind of onion encapsulation with all the layer of SCHC, and we introduce SCHC header that is not mandatory, that can be totally transparent. But for the exercise, we try to put it everywhere. Okay? So in the next slide, we try to see the organization of that. So of course, is maybe Edgar?
Yeah, sorry, I didn't get the part of how do you know that you have another SCHC header inside the first one. So how it is signaled?
It's part of the context. So we have to find a way to say in the context we have a SCHC header.
So in the rule, you specify that you will have another header, and then you can actually decode it from the rule that maps to that.
Yes, exactly. So we don't know yet because it's not easy to see in the best way. So I have to look on OpenSCHC and see how to define these rules. So during the IETF, we made some attempt on where we had compression rule, fragmentation rule, and SCHC header rules. But it doesn't work well because normally the rule ID for SCHC header are independent from the rule ID for compression decompression. So the way we represent it is not completely clear right now because, for example, here you have seed1 that point to a device, and here you have a certain number of compression rule. Then you have seed I, for example, in the middle that point to another set of rules, but you have in common your SCHC header. So the way to represent it in an easy way is not defined right now.
And this apply also to fragments, as I can see there. So it means that you might have rules for fragments and rules for the full packet as well.
Yes, that's a good point. It's still not clear right now, but for example, if you have a session ID, then you need to carry it all the time to tell to which session ID or session you have to send the information. So this applies to fragments, and this applies also to compressed packet. Now, when you have a next stop, so next stop normally will only be used for compression and not to fragmentation, but maybe it's better to carry it in all the packets, on all the SCHC headers.
Thank you.
Ivan?
Hi, Laurent. So it will be like another CDA, but without a field ID? What you mean?
So field ID, all these things are in the compression fragmentation. So what is in green, blue, and purple is not changed.
Yes, but you append like in the set of rules inside the rule, like just saying that there is another here next, something like that.
Yeah, so maybe it's more clear in this For example, in I don't know if I can point out something using the tool, but for example, if you look at the last line, you have IPv6 UDP. So no, maybe not the last line, but let's say the line just before the vertical arrow. So you have a SCHC header before the rule ID in green and the residue of the rule ID. Then you have a SCHC header pointing out to, I think it's COAP here, it's a mistake, pointing to COAP here. Then you have the residue for COAP. Then you may have another SCHC header, and then you have the host core compression. And what I think is important is that all the space where you are numbering your rule ID, so for SCHC header, for blue, green, and purple, are totally independent. So Pascal says that we have something hierarchical. I'm not sure to understand what it means.
Say, just for the sake of it, that you have just rules which can compress IP, UDP, COAP, everything, the whole packet without nesting. And you have different flavors of the IP header, like possibly 4 destination IP. Just say that. So you have 4 rules which describe that piece for values. Well, one rule which basically in enum of 1.4 or something, but maybe you have other variations and you have a few rules. But then for each of those few rules, you might have different compression of the UDP and then different compression of what comes next. So what I was getting at is you could represent that as many lines where you show this rule says IP destination is this, then UDP port is that, then second rule is the same IP header as the first, but the UDP header is different, and it has another port, and then whatever. And you realize that you could have said all those rules have the same beginning, like they all say destination IP is this, but they start variating at the UDP. So they could be, you could represent that as a tree where
but
compression
this is something that is not
for all of them,
linked.
and then the compression of UDP is this for all of them.
So I think this is an optimization of SCHC and not something related to SCHC header.
No, it's not related to SCHC header. I was talking about the rule structure, really. And that's so it's the last slide in the presentation I just made. It was a hint that it's because we discussed it at IETF-SCHC-20230919-1400 that obviously if we do things in layers, we have a lot less of what I just said. Because effectively it's really SCHC within SCHC within SCHC, which caused that tree that I had in mind. But otherwise, you would basically, it was more about the model of how we program and express the rules. If we express them as a tree rather than as a, it's not even a tree, it's probably a graph, by the way. If we represent it as a graph rather than as a number of lines which repeat the other lines for large piece. But it's not even a tree. I think I'm wrong on that. It's probably a graph because you can have different destination IP, and for each of them you might have the same UDP port. I don't know. So it's like you say, it's an optimization, but not an optimization of the rules themselves, but on their representation for the management.
Okay. So Manoj.
Hello, Professor Touton. Just wanted to ask on your slide number 2.
Yes.
There is so the middle block SID prime 1 and SID prime 2. Are these delta encoded SIDs?
No, it's absolutely no SIDs as a core conf. It's just session ID, and unfortunately it's the same name.
Okay. Okay.
Nothing to do with core conf.
Okay, got it. Thank you.
So here it's tried to work on that because it looks quite complex, and I think that when we will handle it a little bit better, it will not be that complex. And so here it shows, or try to show the different steps we have when we do compression on the node. So at the beginning, so forget about UDP, IPv6 UDP co-op. At the beginning, we just have OSCORE message. And so what we do in the second line is that we do the compression. So it means that we have a rule ID saying that how to compress or decompress OSCORE. We have the residues that are related to that rule ID. And then we have the payload. So the next step, normally what we do is to encrypt the information. That's why now it applies in dark in the slide. And next step is to go to co-op. So we add co-op, and just before, sorry, we have to put the SCHC header regarding giving information, maybe a checksum, I don't know, about how we carry this ready. Then we do go to co-op. So to co-op, we do also a compression. And what is important to notice, and it's what Pascal says, is that at the beginning, we had the UDP port should be something that point to co-op. And after the compression, we need a UDP port that point to SCHC, and etc. etc. So after that, we have to send it. So we add also the SCHC header regarding to this layer, and then we do the compression of IP UDP the same way. We add the SCHC header, and the vertical arrow shows that we are sending it on the LP1, and it arrives at the other side. And at the other side, we decompress it and we reconstruct the UDP, IP UDP, carrying the SCHC, the port. So the next header, the port will be SCHC, and then we send it on the internet. So it means that we are in the green box in the middle, and here we create the SCHC header that exists or not, because it can be fully compressed on the context on both sides, or that can carry some bits sending this information. So that's some details on that. So as I say, it's not totally clear. We have to see how we represent it. And the last point that Pascal talked about is how to put the management in that. So in fact, the management, normally we use netconf, coreconf, or restconf. So we will have to define some rules that will do that. So if we go to OSCORE, maybe we can have a special IP address that tells that it's for management on the device. So one possibility, for example, could be to use some anycast address, and even, I don't know if it's possible, some link local anycast addresses to say this is the two element for the management. And this way we may have some specific rules that handle this. But if we are not dealing with IP on the compression, how we can do it, that's still an open question. And the other question is, can we manage the SCHC header rules? And for me, maybe it's too risky to do that, especially the first one, because we have no way to really check who's sending the information. So it's things also we have to put in the architecture. But my last word, Pascal, is that you see that even if we have only one device, we may have different SCHC instances, and it means that we have to identify it internally and externally.
You were talking about the the way we identify the management. And for one thing, there could be a management session. So if we can identify multiple sessions, if you have a session, an IP packet coming in your device from an IP address, blah, to you, and it has a session ID, I don't know, FoxFox, then it's the well-known session ID for management. So it's expected to be a management session. I don't know.
Yeah, that's a possibility. For example, we have session ID 1 for regular things and session ID 2 for management. But in that case, it means that we lose 1 bit on each packet. So I don't know.
Yeah, so I'm
If
just
we lose
listing,
1
right?
bit,
The
we
other,
need-
the other because we discussed it, this 1 bit that we lose because we can't compress the session anymore. There was also basically the point that they have in mind is if you use an anycast something, you have to place the MAC address to the right guy. And so that only works on one hop. But if you
But here
if you want
we
to
are
talk
always
to the
up by
guy,
up. So here we have out by up. Here we are also out by up. So we are only one up.
but if you want to manage a device over IP from a distance, you probably need UDP as well. Remember the encapsulation has UDP. And if you do, then the alternate, if you have a UDP header to do your management, so it's a different format. That's when you do it from remote over UDP. But if you do it from remote over UDP, when we ask for a UDP port which says SCHC, we could also have a second UDP port which does SCHC management. I don't know. It's just something on the table as well.
Okay.
And yeah. And by the way, you lose the bit only if you do management, right? Because the default, you could have a rule which does not have. Oh no. If all the rules you must always have a rule ID if you have more than one. So you will always pay for the rule ID, even if everything else is implicit, as soon as you have more than one.
Yes, if you have only one rule, you don't pay for the rule ID. If you have several rules,
but here, if you have a rule which does not have a session and a rule that has a session in it, then it's 2 rules, you have to pay for the rule ID. So maybe it's easier to have a single rule and pay for the session. I don't know.
Yes, or we can have a rule that say we have in the optional way part, you can say this is a management message. And so this way we, because that's a good question you asked. Do we allow everyone to manage a device, a remote device, or do we just allow the other entities to manage a device?
It's always a packet that you receive anyway. The bottom line is probably you will only allow something which is cozy encrypted. And so it is basically sent by somebody you trust because you have his public key. So you only accept management from a public key that you understand, that you could decrypt from a public with a public key that you accept. That's when Outdoor comes into play. Yeah. So we have reached the end of the hour. I mean that was more that's the beginning of the season, and that's also explaining the kind of problems that we'll be looking at during this season. So thanks so much, Laurent, for explaining all this. For now, we're just exploring, right? We are just laying out in front of you guys what kind of problems we will be considering for this season, but we don't have the answers. We are looking at how we want to structure this and express it. What's very clear for us is we need this IPv6 header, even if it doesn't really fly in the air. It could, but only in a very small domain. And we will need to ask IPv6 6man for that header value. And we know it's going to be a fight. At the same time, we are also, Bob just sent me an email saying he could not be with us today, but we're also considering asking for an ether type and the next header to say, well, it was not initially next header, it was a protocol type. But what we just discussed now, it's more than a protocol type, it's really a next header, meaning effectively there can be an IPv6 header. It's not considered as a URP. It's a next header. And initially in the discussion, people were not clear on that, but I guess now we are getting very, very clear that it's an extension header, because after that you have any URP that you compress. That's pretty much it for me. So do we have any question or famous last words before we adjourn? Okay, I see that we're all set. So thank you all for the participation, and thanks for the minute takers. I guess that was enough for the most piece. I didn't really look at who was taking them, but yes, big thanks to the minute takers, and I will upload all this to the site.
Hello.
You guys take care. Bye-bye. Dominique, you wanted to say something? No. Okay, bye-bye.
Say bye-bye.
No more sound.